All right. So this is it, the final review. And this is interesting. So my fairy card today was Let Love Be Your Beacon. So when you watch my last lab, I thought that was really appropriate. And I look forward. So a question that Ryan had asked me, because I didn't give you much instruction, that lab, you just have to watch the video, and at the end, and you just then write 1 to 2 pages about your thoughts. There's not a right or wrong, and then you upload it. And then the other, that's 10 points. And the other 5 points of the lab will be your reviews for the demo videos. I'm sorry, the demo presentations, just like last time. And again, if you're presenting, maybe you'll be watching this after. So comments about your final. It is multiple choice. You're going to do it on Zoom. It will show up tomorrow. Today's Tuesday. It will show up Thursday. So starting tonight and then all day tomorrow is all about the demos. And for your demos, I'll be there 20 minutes early for each time. And 20 minutes I can stay after. So if you have questions, that would be better to talk to me then. Like if you have questions about the final, we can discuss then. You can take it anytime. If you want, if you're somebody who's like, I just want to be done, I'm taking it Thursday, you can take it Thursday. And if you want to like sleep for a day or two and then take it, you can also do that. So it will be open until Saturday. And the other thing is, I'm pretty sure, you can let me know when you come do the demo, your first exam, multiple choice, should have reopened, not to redo it. You can actually redo it. It doesn't give you a new grade, but you can try it again. And it will tell you the answers. So if you just want practice with the time, for just doing multiple choice, so you don't feel like, oh, this is a whole new format. A comment I made on the top of the review, I have my old review here, is you're going to see a number. So you're going to take the test and it will probably tell you got, let's say 50. And you're going to be like, oh my God, I only got 50 out of 75. And then I'll get all these panicked emails. So I'm like in a panic about this because I have watched the students. Yeah, just let it go, because I then have to go. There's a curve built into the test. And so basically you can miss like 4 or 5 and have 100%. It's a percentile, not a percentage. So they gave the test to like thousands of students, and then they looked at how many they got right, and they made a bell-shaped curve. And so it's where you fall on the bell-shaped curve. And so it's really generous in the first half of the curve, and then it has a steep downhill. So it has a slow uphill and hits the top, and then it goes downhill. So you want to be in that uphill part. That's why you guys have an advantage. In the past, we always were done Thursday, and then I left and went into silence. And so, and since we're not allowed to do anything except go to the stores and go to bars, apparently, you guys have till Saturday to do it. Presentations are before that. Your presentations and your report are worth a lot of points. So do a great job. A lot of you are going to watch this after that, but if you do listen before that, I'll probably send an email if I get a chance to breathe. The evening, Wednesday evening, is the biggest group. There's 10 of you, which is how big our other groups were. There is a Wednesday 4 o'clock now that I opened up. And so if you want to switch, I just need like 1 or 2 people. So if you're like, yeah, I'd rather do 4 o'clock, send me an email. You do have to write a report on it. I did post like a thing under syllabus, but several people have been asking me. So the report, the first 2 to 3 pages, depending how much you write, that's where you write an intro about the background. That's like what you usually read before, or you're supposed to read. And then your procedure, and then some post-lab questions. When you do your demo, you can ask the audience your post-lab questions and see if any of us know when you get done. And then your last page will be your lab report. So abstract, your data, the data table will be different depending on your presentation. That's like real quick and stuff. and I can answer questions more also when people do their presentations. Do any of you guys have questions for me before we start? The question Aaron asked me and somebody else did before was, this is a note to me because I teach a kids class, but it's online now, so I don't know if you guys are allowed to help me. I have to find out. I usually need lots of help because I usually have lots of kids, but I limited myself. He asked, and it's a question everybody always asks, so if I just do study set 8, so study set 7 is the complex ions, study set 8, if you do the whole thing, you get 8 points. It's worth 5 points, so you get bonus 3 points. So just do the whole thing. I've had students who that's all they've done, and they felt they did fine. I've had students who don't do the whole thing. I will say this, the students who don't do that study set never do well. So it's not that, yeah. And doing the review, it just helps to get things going. There's a lot of questions that you just go with it. You guys can't dwell. It's different when it's paper and pencil, but when it's on the screen, that timer, I know you were all obsessing about it in the first exam, that timer is your friend. Change your perspective and be grateful you have a timer there so you know that you're pacing yourself fine. And just answer every question. You can make sure you have a periodic table and your calculator ready before you hit go. You don't have to sit there and fill out a Scantron. You'll just click and go. There are, out of the 75 questions, I know one time I figured it out, there's maybe at most 15 that are math questions, meaning working something out. So make sure you have scratch paper. We're going to do a handful today. Like, we pretty much do all the math ones that are on there. A lot of the questions should only take like 10-20 seconds. The math ones will, of course, take a little bit more time. But if you get stuck, you can't dwell. You can't spend 10 minutes on one question. Take your best guess, make a note. I want to go back and look at that. They're randomized, so they're going to be a different order for everyone. So just kind of keep that in mind. And you will not see, you'll see how many questions you got, but you don't ever get to see the answers and stuff. All right, let's go ahead and start going through this. This is just to get things. It was a question Aaron also asked, more for those of you who had me. He said, hey, the 222 videos are still there. So he was gonna like watch all of those, which would be insane, Aaron. I think if you, what I would tell you is go through this review, go do that homework set, and if there's something like, hopefully, well, maybe like this first one, you're like, I don't remember what electrons, neutrons, and protons are. That's 221. You might want to go back and look over a little bit of that and refresh. Or like when we do alpha and beta decay, there's one question. There's a lot of stuff we're going to cover here, and so yeah. And the bulk of it really is from this term, and a lot of it, I mean, there's a big section on oxidation reduction. It might not seem like it to you, and also in thermodynamics, and also equilibrium. So probably half the test is stuff from this term. All right, we're going to do, hopefully you know your periodic table. And so iron 55, that pen's not going to work. And looking at our periodic table, so iron is the atomic number, 26 protons, 26 electrons. And then the neutrons we would subtract. So the 55 is the total number of nucleons, right? What's in there. And so we subtract, and that gives us, what, 29 neutrons. So if you take this 55 and subtract the 26, that's where we get our neutrons. Oops, that's where I'm up in that funky zone. So neutrons. And then electron configuration. So it's not show your work. You can be as messy as you want to be and showing your, don't have to show units and stuff. Yeah. So this, a couple of you have actually already done study set 7. Study set 7 gives you actually a lot of review also. So complex ions, there's one question on complex ions, but it has you go back and do these. Do you guys remember? You find iron on your periodic table, noble gas, we would start with argon. So here's argon. After argon, we're here, right? Those of you who are with me, 1, 2, 3, 4, 5, 6, 7. We're in the 4th row. We're in the 4 S's. There's 2 electrons in the S's. I will have office hours. I said on Wednesday, because we're in class presentation, I'll just be available right before and after your presentation. But I'll have an office hour Thursday and Friday. Probably an hour in the morning and an hour in the evening if you have a question and want to pop in. Yeah. And then we have to go into here, and these are the 3Ds, and we count over to iron, so 3D6. It would be more, they would show you a picture and say, what element is this? The reminder that I go through in study set 7 is if this has a charge, if we gave the iron a charge, you lose the S electrons. All right, unpaired electrons would be in the Ds, and again, those have 5 orbitals. It's not going to, back to like, you didn't ask me this question, Erin, but back in 221, you guys learned S's have 1 orbital, Ds have 5 orbitals. You're not going to see a question like that. It would, yeah. But you would have 5, 6. We would have 4 unpaired electrons, and it is paramagnetic. If there are unpaired electrons, it is paramagnetic. Means it has a magnetic moment. Something that's really cool. Iron is what's called ferromagnetic. It sticks to your refrigerator. That's what our magnets are made out of. As is cobalt and nickel. They're the only 3 elements that will stick to your refrigerator. Cobalt is in the, iron's in the center of our blood cells. Cobalt is in the center of vitamin B12. And it is actually believed that is why you need B12. And it turns out bacteria in the soil is what makes it. And people who eat meat are actually more devoid of it now because of how we feed cattle. Not like nice cattle like Juliana has, but which doesn't eat them. So people, if you're vegetarian, yeah, it's actually your gut bacteria also that helps. But anyway, the cobalt in the B12, they believe the B12, the cobalt is wound up magnetically, and it helps to magnetize the iron in your blood. And if you've ever seen a blood cell, a picture of a red blood cell, it looks like a magnetic field. And they think that's actually an oxygen is also paramagnetic as O2. The diatomic is paramagnetic. That's back with molecular orbitals. And so they think that's actually the whole thing that's going on. Not they, the doctors, like the people behind the scenes, that it's all magnetism that is attracting that. And all right, anyway, it's pretty cool. Let's move on. So go ahead.
Well, I just wanted to ask the 3Ds. So does it? I'm trying to remember. So does it start with 3 and then like that first row?
Yeah, these are the 3Ds, 4Ds, 5Ds. Those would be the 6Ds.
Okay, cool. Yeah, and I'm wondering, will we see anything from F block? Or is that too specific?
I don't know. You know, it's really hard because sometimes I don't really remember those questions because I just see them and I know it. I don't think so.
Okay.
I think,
cool.
yeah, there's so much stuff. So all these little pieces. All right, this question too has actually many dimensions to it. It's probably a big question here. Oxidation numbers. You definitely will have an oxidation number question. You're going to have a question about ionic and covalent, and you're going to have a question about electrolytes. So it's kind of 3 different questions showing up here. We're going to do oxidation numbers last. Ionic is metal, non-metal. So C and A are ionic. I mean, ClO4, it is an ion. And so they are also electrolytes. So things that are ionic are going to act as electrolytes. Acids and bases are also electrolytes because when they're in water, they will ionize. Molecules, so POCl5 is covalent. if you're over here in this part of the periodic table, if that's all you have is carbons, hydrogens, nitrogens, phosphorus, sulfur, it is a covalent bond. They are not electrolytes. They do not form ions. Another term for covalent is molecular. So a molecule means you have only covalent bonds there. So pockle, so these guys combine in all different ways. They end up being extremely toxic, and we'll see why in a moment, because the phosphorus is going to have an outrageous oxidation number. So there will be a question. It really should only take you like 20 seconds to do it, where it will give you a, you know, A, B, C, D, E, which one is ionic or which one is covalent, and also about electrolytes. So electrolytes, again, ionic acid bases will also conduct. All right. So you need something that's aqueous. Oxidation numbers. So the ClO4, you do the one that is more electronegative first. So electronegativity is moving towards this corner in the periodic table, came from Linus Pauling. Fluorine is the greediest. So whatever is closest to fluorine, we give them their normal oxidation state. So oxygen likes to be a -2. There's 4 oxygens. So the -2 is its oxidation state. I'm going to do my math down below. And so -2 times 4 is -8. When we add this all up, though, that's the -1 means when we add all the oxidation numbers of all the atoms in this compound, we're going to end up at -1. So that makes the chlorine a +7. This guy is extremely reactive. It doesn't make sense. Chlorine, why would it want to be a +7? I mean, that would knock it way back. This is perchlorate ion, and it's our strongest acid because of all those oxygens. All right, on the next one, the nonmetals that are greedy, the last one, the phosphorus, has to take all the positive. The other one's going to be greedy, and they're going to be pooling. The phosphorus would be in the center, and the other ones would be on the outside pooling. Oxygen's going to be -2, and this time chlorine gets to be its -1, but there's 5 of them. So that means we're at a +7 again for the P. A lot of these numbers, they're like, this doesn't make sense. I know when I teach it, my students will be like, that doesn't make sense. That's the point. To a chemist, you look at this and you go, wow, that's a reactive, that's toxic. This is a super fun site. All right, and then on this one, the chloride is again a -1. So on B and C, the chlorine's oxidation number makes sense, and the iron would take a +3. It's going to balance. So we'd call it iron 3 chloride. I know I didn't ask you to name, but there's like 1, maybe 2 naming things on there, and you either know it or you don't. But we call it chloride, IDE, because that's all we got. All right. Oh, this one, 351 nanometers. So time, it is a time test. You might want to make a note card, or on your periodic table, you might want to, before starting the test, because once it starts, the timer goes. You don't get to take breaks. And you can go to the bathroom, but the timer keeps going. But you might want to make a couple of your constants up there in case you don't know them. But we're going to change our wavelength to frequency and to energy. This is really fun stuff. So wavelength times frequency equals c, which is the speed of light. This is the symbol for wavelength. You can use any symbol you want since it's multiple choice. That funky F is frequency. They've changed the symbol because so many students couldn't tell the difference between frequency and velocity. And then c is the speed of light, which is, does anybody remember? You can do 2.998, but really 3 is going to be good enough. 3 times 10 to the 8th meters per second. That's back from the end of 221 for us. Nanometers, you're going to have to change to meters. Just remember what a nano is? So a nanometer is
10 to the negative 12.
9. Nano is 9. It looks like a 9. The words go together. So nano is 9. So it's 10 to negative 9 meters. Or you can do 10 to 9 nanometers so a billion nanometers in a meter. And you would solve for frequency. And then once you have frequency, for those of you who want to solve for it, I'm just going to write a number here for you because I did it many years ago. So you'll get around 8.54 e to the 14th. It is hertz. Hertz means, if you don't like that unit, the unit is per second. So it's cycles or waves per second, or cycles per second is actually how they talk about it. The second equation to use is E equals H times frequency. And again, I'm using that symbol because I honestly don't know what symbol your other teachers used. You can use a funky V. It doesn't matter. It's multiple choice. So this is our frequency we would plug in, and Planck's constant, 6.626 e to the negative 34th. It's a number that is inconceivable. We've worked with a lot of numbers that make no sense this term, but they're just telling us, does it go left or does it go right? All right, this is going to be joules per photon, joules times seconds per photon. And you would punch in and you would get a number. I didn't give myself enough room, but once you plug those two in, you would get a number, 5.66. You have one of these on the homework set. The homework set, I only gave the answers. So you do have to show your work. You'll have to do your own work. And you can send me an email or check into office hours if you have a question. I'm not going to be here for like 4 hours a day like I have been on Thursday and Friday, but you can send me an email and say, hey, will you be in the 11 o'clock office hour? And I will respond and be there. All right. This is what we get from that step. If it's a chemistry question, they will often have you go to moles. And as you know, in chemical equations, we use kilojoules. So you guys all have in the past week done a lot of times going from joules to kilojoules, so 1,000 joules in a kilojoule. And photons to moles is Avogadro's number. So if you don't know it, you can write it on your periodic table, but 6.022 times 10 to the 23rd photons per mole. So like there's that many atoms in a mole. A photon is a particle of light. It's, was Planck's idea, and it allows us to do the math to try to explain how light works and how vibrations work and create matter. So it's one question. I wouldn't spend hours on it, but going back and punching them in, you can do this one again. You can ask me. We're gonna move on. Oh, quantum numbers. You guys remember these? It's gonna be one question, but let's walk through it. The N number is your shell. The L number is the subshell. And then the ML was the orientation. The MS is the spin. Remember, electrons can spin clockwise or counterclockwise. And we're just looking to see if it's a good line or not. I can already see B is no good. So the L has to be a positive number. It can be anything from 0 to less than N. So the L always has to be a number less than N. And then the ML can be anything from positive L to negative L, or negative L to positive L. And so all those L's are good, or the MLs, sorry. That's for the ML numbers. And then the MS's are just spins of positive or negative. So the first one's fine. The second one is the one that's no good because the L cannot be a negative number. And then the other two are actually perfectly fine. MLs can be negative. They just have to go from negative L to positive L. All right, that's like a really quick review. It'd be one question. I don't even remember that quantum numbers are on there. But question 5 is actually a good question. There's actually a lot of questions that require you to have some knowledge of the periodic table because it is a chemistry thing. So atom A, this actually goes more back with the orbital stuff. If it's 3s1, this would be sodium, right? So the third row in the first box. And if we're here at 3p5, we'd be over at chlorine. So recognizing what atoms you have there, the one that forms a cation, cations are positive, so that would be A. Sodium would definitely form a cation. The metals are also the cations, so again, A is going to form the cation. Ionization energy, it follows the same trend as electronegativity, so chlorine wins this one. So as you move across the periodic table, their energy of ionization becomes higher. Ionization energy was to pull an electron off. Radius is the opposite of ionization energy. So, sorry, I wrote chlorine, that would be B. And electronegativity would again be the chloride or atom B. So periodic trends, again, go catacorner. Electronegativity, right? Ionization energy, we're moving up to this corner here. Atomic radius is the exact opposite. So francium would be our largest. And, oh, alpha and beta decay. All right, write your symbols. Silver, 111, 47. And beta particle, you don't actually have to write this out. I'm writing it out to help remind you. The mass does not change. The atomic number goes up by 1 because that's how the math works out. It's actually easier to do with the periodic table that you're here at silver. Beta particle always moves to the next one because it's a neutron that becomes a proton. So we would end up with cadmium. And again, since it's multiple choice, and if you know that trick, there's one question about nuclear on there. So just refreshing what alpha and beta is, you'll probably get it. All right. The number 231 tells you on the periodic table you're down near at the bottom somewhere. And so there's PA, it's number 91. Alpha decay is huge weight loss. So a review, alpha decay means you're losing, or it's like our best way to lose a lot of mass. And so it tends to be the large elements tend to go through alpha decay because it's a way for them to get rid of a lot of mass in their nucleus. Nuclear chemistry is because the nucleus is not stable, and it's often because it's just too big. So we're going to end up, it always loses 4 from the top, a mass of 4, and the atomic number drops down by 2 because you're losing 2 protons and 2 neutrons at one time. So if we're at 91, we're now at 89, which is AC. And again, right, neon is number 10. Fluorine is number 9. The 2 sides have to be equal. This is not beta. This is going to be a positron. And I mentioned that because it will either be, it will probably be words. But the symbol for a positron is the same as a beta particle, but with a +1 instead of a -1. All right, we good? We can move on from first page. All right. Oh, good. So, you guys, I can give you a chance to try these. If you're watching at home, I would tell you to stop my video now and try this page. Or try 1 and 2 and then watch me do them. If you guys watch, you guys who are here, do you want 10 minutes to do some math, or you want me to just go for it?
It would actually, I'd like that.
Okay, I'm gonna pause. So I'm back. Maybe you never left. There is definitely an empirical formula. So again, there are not a lot of math questions. I think there's like 12. There is they're either moles, a couple mole questions like on this page. That's why these questions are here. There is an empirical formula. There is not empirical formula from combustion. I don't know if you guys remember that from back in 221. It's just a regular empirical formula. The other math ones are like what we just did. So they're either equilibrium questions, titration question, a buffer question, thermodynamics, what you just had on your test, a redox question, maybe. I'm trying to think. And the study set actually has those. You do definitely, again, do that whole study set 8 because you get bonus points. And then the second half is a lot from this term, and it will help to have those fresh so you're good to go. A lot of people will do it the day that they're going to do the test so that it's kind of fresh in their mind. You want to take, the way I do it is you just take your percents and make them into grams. You can take it, but you're going to have to go to Winco for the green rice. All right, hydrogen, and the rest is oxygen. So you would subtract from 100. So that's how much, I just assume that we have 100 grams since it's a percent. So 100 grams would be our assumption. You would change grams to moles. Now, a quick comment. It's a question that Aaron asked about Sig Figs. Sig Figs are not important here. They're going to do everything with 2 or 3 Sig Figs. You can round your periodic table to 12 grams for 1 gram per mole for hydrogen, and of course, oxygen. So this is a question that Aaron asked me while I had the camera that had it stopped recording. Empirical formula is not diatomics. It is just oxygen. If you do it as O2, as 32, you can still get the right answer. You just have to remember you did it as O2. But we get numbers here, which will be our moles. 2.25, 2.01, 2.22, right? I like to write my units so I know where I am. You're going to divide by the smallest number, which is 2.01. You don't have to show all your work because it's multiple choice. You will then get, I'm sorry, I did something. I wrote the numbers down wrong. I just realized this is going to be I skipped a step, 4.49. And when this is going to be 4.998 or 5. And this was our 2.22. So you're going to divide by the 2.22. Sorry, I couldn't read my own notes. You don't have to, you can write it down. Just make sure you have scratch paper so you can write it down. When you do this, you will get that this will be, the oxygen will be 1. This will be 2, and this will be 2.25. And so this is where you have to multiply them all by 4. So you get C9H8O4. So Aaron's question, more in case this happened to somebody else, he had done this as O2. So all these numbers were half, and he got C9H8O2, but it's O2 too, so it's O4. So it comes out the same. Empirical formula is the lowest whole number ratio. There are other ways you can do these, but there is definitely an empirical formula on there. Every version of this test has had an empirical formula. When they take samples from Mars and they send it back, it's empirical formula they're doing to figure out what the rock is made out of, to figure out what they have. So they have percentages by mass of everything, and then they do an empirical formula to figure it out. All right, I'm not going to go through all of this. The quartz is the SiO2, and then you have 42 grams of carbon. And you would solve this. And it wants to know how much carbon monoxide is made. You guys know how to do this, right? You change your grams to moles, you do your mole to mole ratio. SiO2 would be 32. This is, I think, 60 in my head, 60 grams of SiO2. Your mole to mole ratio. In all honesty, the students who work it out end up getting it right, and it's kind of a calming thing to do the math. And this is just me walking through all your steps. So 12 to 16, 28 grams of CO, and from the SiO2 we get this number. And you can go through the same thing with the carbon. You get 65.3 grams, which is your excess, so we don't care about that. You also might see where it asks you, oh, this is a percent yield. So you could see, it could also ask you, it might have two pieces to the answer. 39.2 grams of carbon monoxide is made and 0 grams of SiO2 is left. You have some carbon left. This is just, remember, you do actual over theoretic equals percent. They have to give you actual, the calculated number up here. Doing the stoichiometry is your theoretic. So actual over theoretic equals percent. And so that's where the percent's coming from. You got to walk through these and do them. And that's in the homework. You'll have these. It's just to bring it back so it's fresh. I don't think you need to go back and redo all your stuff from 221 and 222. If you do something, you're like, I really don't remember how to do moles. Well, I really don't know how you got this far in my class. But right, this one's also a factor label with a delta H. So if we start with the liter, oh, a really good question that often comes up. Back in the beginning of 221, some of you learned stuff where you worked with like gallons or pounds, right? And doing the conversions between US and metric. There's nothing US. US units are totally obsolete, or the imperial units. So there's nothing about that. So you don't have to worry about that. I'm going to use density. That's symbol for density. So a liter is 1,000 mils. And then 0.782 grams per milliliter. And then it's ethanol, which would be 46 grams of the C2H5OH. We know it must be this one because that's oxygen, carbon dioxide, and water. So that must be the ethanol to 1 mole. And then in our balanced equation, since there's no coefficient there, for every 1 mole of the C2H5OH, you get 2,822 kilojoules. Now, if it had asked about oxygen, this number here would be 3 moles. This number has to be from the balanced equation. So if it asked about CO2, we would have had 2 moles of CO2. Delta H's of the reaction, delta G's of a reaction are just kilojoules because it is based on the stoichiometry. It's not necessarily per mole, it's per whatever the stoichiometry is. This is also something I think I mentioned when I was off camera to the group that's here. The answers may actually have pluses and minuses. So when you're doing thermodynamics, so our answer would have a negative. So you can all sit there and say, why doesn't she have a negative? I don't know. I just never go back and fix that. All right, next one. Oh, this is gas laws. There are 2 different ways you could do this one. STP means 273 Kelvin and 1 ATM. So I just wanted to remind you of that. Standard temperature is 298 for everything else, what we did this term. And standard temperature in gas laws is 273. It's 0 Celsius. So if you have 0 Celsius, or whatever temperature you have in Celsius, you add 273. You can do PV equals nRT. We've had that several times on worksheets or study sets because there's 1 or 2 gas laws on there. You're solving for moles because it's chemistry and we're all about moles. So I would divide by RT. That is going to give me the moles of oxygen because that is the gas. And again, just in the interest of time, I'm not going to walk through all the math pieces. This is going to give you, I'll just say XX moles of oxygen. And then, oh, I'm sorry. We are trying to solve for volume. Maybe your teacher should read the question first. That would be our last step. So you're going to start with the 12 grams. That's because I wrote this like 20 years ago, so I don't remember what 20 years ago. Do you guys remember what you were thinking 20 years ago? Some of you weren't born yet. So you were having very expansive thoughts 20 years ago if you weren't yet in this physicality. Anyway, you're going to change this, right? There's 24.3 grams to 1 mole of magnesium. And then you don't have to try and write this. We would have our 2 moles of magnesium to our 1 mole of oxygen. You have to get to oxygen because it's a gas. That will now plug into the N and you can solve for volume by dividing by P. You should use a pencil one of these days. This doesn't look like such a mess. Yeah. So your pressure would be 1 atm. There's actually another way you can do it. I mention this because some of you may have had your teacher show you this. This trick only works at STP, and that's the 22.4 liters per mole. It's a number some people like to memorize, and it only works at STP, that every gas occupies 22.4 liters per mole at STP, because somebody went through and did all the math. The R you're using here is actually the other key, 0.082. Now, there's been a couple questions because people said, oh, I learned it different from different teachers. You all learned these first 3 digits the same, 0.082. And then you can go to 1. 3 Sig Figs is going to be enough, or 0.57. This is, both R's show up on the test. They've both shown up this term. This is the one when you're working with ATM liters per mole K. So this question is dealing with STP. We used it the first study set, first worksheet, I think somewhere in there. It's also the R you use with osmotic pressure. So if you ran into osmotic pressure, you can do with PV equals nRT. All right, and then the last one on the page, there is a freezing point question. So this is that change in temperature equals K times that little m. This little m stands for moles per kilogram. The K, of course, would be given to you, which is there. This is the change in the temperature. So we have 4.1 and 5.5. Now, this is taught different ways in every book you look. So they sometimes put a negative here. I always teach it, I do now teach it as absolute value because it is different on different websites. When you add something, a solute, the freezing point always drops. And so the difference in the freezing points is going to be, sorry, I'll move it over here, that we would take our delta T and divide by the K. So we'd have 1.4 degrees Celsius. We would divide by our K. And this will give us, and some people do this all in one step, and that's beautiful. That's great. What I found is half the time you don't get it right doing it in one step. If you already got it and you know what you're doing, you can hit the fast forward 30-second button and go to the next question. This number that you get, this is not moles, this is moles per kilogram. It is a warning I will give you of doing things fast and abbreviating moles as M. It is never an M because that little m means moles per kilogram. So which mass do we use? We use the one that is the solvent. So it's solute over solvent. And the solvent is always the larger of the two masses. So we would multiply by the 0.1 kilograms, which is this guy. That's going to get rid of that kilograms. We have 0.0273 moles. And we're not done. I break it into steps because logically it makes it easier to talk about. At 5 grams divided by your moles, molar mass, molecular weight means how many grams per mole do you get. It's not asking you what element, it's just wanting you to solve for that. And again, you guys have all come from like 6 different teachers and everybody has their tricks for teaching this. And if your teacher had this elegant trick, awesome, it's one question. But this is just to remind you to go back and say, okay, and you got that one question. There's 74 other ones too. The biggest factor is to be relaxed and calm and to get a good night's sleep. You guys have a huge advantage they've never had before. We all just took it Thursday and we were done and we moved on. So in fact, that's probably a disadvantage because we just did it and moved on. You guys can decide, I need sleep, and take Thursday off and just sleep all day. And then study and do it on Friday, which is a good thing. Make sure you get a good night's sleep. Math, the other math is the math we did this term. We're gonna do some Lewis structures now. So I'm gonna walk through the first one, and then I'll give you guys a couple minutes to try doing your own Lewis structures. But you will see where you have pictures. We're going to talk about isomers in a moment. I talked about them some with the study set 7 video. Sigma bonds, every bond's a sigma bond, pi bond. Remember, a double bond is 1 sigma, 1 pi bond. This means the overlap is in a different plane. So there's 1 pi bond, and then if we count 1, 2, 3, 4, 5, 6, 7, there's 8 sigma bonds. If you have a triple bond is 1 pi, I'm sorry, 2 pi's and 1 sigma. Triple bonds are very rare. I'm not sure if they exist in nature. The hybridization, we've seen this question twice on worksheets. So my first carbon is sp3. Tetrahedrals are sp3s. My middle carbon is sp2, and you guys all got it. And so I'm hoping it's because you were like, oh yeah, I enjoyed that. Or you just copied. It's not going to work so well in the final. I want to do the nitrogen also. And I want to remind you something I know I talked about in 222 with my class. They often leave the dots off the nitrogen. The nitrogen has to obey the octet rule. And so this is an sp3 also. Oxygens, they often leave the dots off too. It has 2 bonds and then 2 sets of dots. I want to mention isomers. I know I didn't ask it on here, but an isomer is where we rearrange. The key with isomers is that double bond or the oxygen. The oxygen could move to the outside carbon. Oxygen is going to make 2 bonds. Carbon makes 4 bonds, period. It's going to make 4 bonds. If you saw a carbon with 3 bonds, something is wrong. If you saw a carbon with 5 bonds, something is wrong. That's really the essence of everything in organic chemistry. Nitrogens make 3 bonds. So you could put the double bond between the carbons. If you did that, you have to take a hydrogen off. This would have to become a single bond, and the hydrogen would come on the oxygen. That would be an isomer. So without counting all the hydrogens and stuff, We just move the double bond. Everything still has, the carbon still have 4 bonds, and the oxygen still has 2. We just moved the hydrogen from where it was. So I know there's a question like that, just has pictures and says which of these would be an acceptable isomer. You can't end up with a carbon with only 3 bonds. That's not going to work. You're not going to get an oxygen with 3 bonds. Oxygen would blow the whole thing apart. So you can draw lots of things on paper. It doesn't mean it's right. Lewis structures. That's why you want your paper there. So this is going to come out. You can count your electrons. You're going to have 26. So go back and practice. You're going to have a lone pair up there because there's going to be 26 electrons. So there are 4 things around the phosphorus. This is a tetrahedral. But because there's a lone pair, it might call it a tetrahedron. It doesn't really matter. This is a trigonal pyramid or just a pyramidal or a pyramid. Just saying it's a triangle-based pyramid. The bond angles are around 109. This one actually is, or it's 107.5, but and because of there is a pool, the fluorines are going to be pooling. Tetrahedrals are sp3. Bringing back good memories. Most people, this is why most people like 222. This is the sweet spot, is that you get to spend the first half of the term. It's really not fair comparing 222 to 223. 222 is the easiest one by and far because of this, and gas laws. And 223 is like a whole new game. It should have a higher level on it. When you have a negative charge, it just means you have to add an electron to your total. You want to keep the oxygens on the outside because they're greedy. I want to remind you, you're going to get, this is one where you get a double and a single bond. So that's a double. No, it looks like a triple. I'm just jumping to the chase here. Those of you at home can stop me. This is a resonance. I don't know if a resonance would be when you have a double and a single bond. That double bond actually is in both places, but we show it like this to show the electrons correctly. That was part of Linus Pauling's Nobel Prize. And students will ask me, do you have to show the bracket? It doesn't matter, it's multiple choice. You're gonna be looking at their pictures. I recommend with Lewis structures, you make a sketch and then look at their pictures. This has 1, 2, 3 things. So the pairs, so this is a triangle planar or planar or trigonal. Doesn't matter the order. That word planar is important because it's saying it's flat, it's 2-dimensional, and it's also bent. That's kind of how I drew it. It is how I drew it. So the lone pair actually pushes the oxygens down, and that makes it polar because the oxygens are pooling. So you might see a question like that, what's pooling? The oxygens are going to be the part that's pooling. We also had a way where we would show it, where we would show partial negativities. I know I did this at one point this term, and the nitrogen, as crazy as this seems, the nitrogen gets the partial positive area, and because the oxygens are so greedy. So the one that's greedier, which is why I'm wearing my non, fluorine, oxygen, nitrogen, but it's in that order. The fluorine's the greediest. sp2. So going back and doing this page, it's good practice. All right. So this one has a lot of electrons. I get 36. So go ahead and make your sketch. And it's not, the test is not going to be like, hey, draw a Lewis structure. It's more going to either have 5 Lewis structures like A, B, C, D, E, and actually let's go ahead and draw this one. The greedy ones are on the outside. They want their own electrons. So sometimes you might not have to draw structures at all. You might be able to just look at the pictures. You're going to have extra electrons, and the extras always go on the center. So the ones on the outside do not break the octet rule. They will have their octet. The only exceptions to that is hydrogen. Hydrogen always just makes a bond, period. Halogens, by the way, they do not double bond. They're one away from being perfect, so they make one bond. This is octahedral. So octahedral show up a lot with the complex ions. So again, when you do your study set 7, that will give you some review with some of these words. So you just have to recognize. So rather than saying, I don't like multiple choice, saying, oh, multiple choice is wonderful because all the answers are there. You just have to recognize the word. You don't have to find the word in your brain. And then it's a square planar. And so 90 degrees because it's a square. And it's non-polar, which is weird, but the fluorines all cancel out. This is sp3d2. So you cannot go past, there's 6 things around the center. So S, 3 Ps, and 2 Ds. So that's what octahedral is. You could see a question where it just shows you A, B, C, D, E, and it says which one's polar. And so you don't have to draw them all out. You would just look at each one. So this one, everything cancels. This one, of course, 2 of them would be polar. Or it could just say like NO2 negative. In NO2 negative, what would the structure be? And it's not going to give you any pictures. It would say bent, and the oxygens are more, have the negative area, or linear, and it's non-polar. So in a case like that, you'd want to make a sketch and think, okay, the oxygens are what's pooling. So they have the negative area. That was a quick review of Lewis structures, but you'll see questions here and there. A little bit different from showing your work, but all right. Several people have asked me about intermolecular forces, IMFs, and they probably are going to show up in a lot of the demos. And so also see that when you do your demo presentation, it's a chance for you to bring some words back, not just for yourself, but for your audience. So ask us some questions that might help for people to remember stuff for the final. As a biochemist, the first one I noticed is the one with the OH. That's an H bond. So just looking at those, I'm like, oh, that's the H bond. So if you see a hydrogen attached to a nitrogen, an oxygen, or a fluorine, so that's my NOF, my hat that I'm wearing. Nitrogen, oxygen, fluorine, again, are 3 most electronegative. That makes an H bond. Water, of course, is an H bond, and that's why we obsess about it in biochemistry. Question Aaron asked me much earlier, before we started recording. H bonds are attractions. So it's more clarification of something you said, Aaron. They're an attraction. They hold them together, but they're not glued together. So they are like a zipper. They can come apart by jiggling and pulling them apart. A covalent bond, when I teach it, covalent bonds are like your arm, your shoulder. It's stuck there. No matter how much you jiggle, it is not going to come apart. You need a chainsaw to make your arm come off. Now, good thing. Don't try that demo at home. Nobody do a demo with a chainsaw cutting their arm off. But that would be a chemical reaction. Break a covalent bond, you need something big to happen, which is going to be a chemical reaction. These guys, these intermolecular forces, we can wiggle them apart, which means heating them to boiling. This guy, the polar, non-polar, the whole point of that was to be able to do these. This guy is non-polar. because it's only carbon and hydrogen. This side of the periodic table is the greedy ones, especially NOF. This whole corner here, there is nothing, carbons and hydrogens do not pool. This goes back to when we did acids and bases also. The carbon-hydrogen part never was the acid-base, it was the OH part. And so this is going to be, there's different words. London dispersion forces, they're also called van der Waals forces, but they don't use that. The newer term is induced dipole. Yeah. All right, pH3 is going to look just like the PF3, so that is polar. You don't have to make the sketch. You can tell, well, phosphorus is here and hydrogen's way over there. So the intermolecular force is called a dipole because there's going to be a polarity. Nitrogen, diatomics are always nonpolar, so we're back to London or induced dipole. So I want to talk about pH3. I'll draw it up here real quick. And it has to do with the polarity. So it has 8 electrons, this is what it looks like. The pool, it's very rare to have this, and it happens when you have hydrogen. Hydrogens do not pool. The other piece always pools. So it's something weird that happens. The phosphorus, the inside gets the negative, and the outside gets the positive area. So the phosphorus is going to be doing the pooling. That's a real quick, with intermolecular forces, there'd be 2 other possible questions we could see there. One is water solubility. You're looking for things that are polar, so B and D, because something has to be pooling. Non-polar doesn't like water, so hydrophobic. They don't use that word, unfortunately. The other thing would be which of these would have the highest boiling point, and it's going to be the H bond would have the highest boiling point if you were comparing boiling points. So you guys probably remember the stronger the intermolecular force. The lowest would be the London's and its size. So this would have our lowest boiling point. So London's will always be the lowest boiling point, and the smaller they are, the lower the boiling point. So nitrogen is definitely smaller than the benzene. The benzene is actually a liquid at room temperature because it's got a large enough surface area. All right. Oh, that's actually the next question. It wants us to do boiling point. So you want to look, these 2 are both nonpolar. They're diatomics. Fluorine to fluorine, chlorine to chlorine. So you look at size. Chlorine wins because it's a greater size, greater surface area. All right, the next one, automatically, I see the HF. We got an H bond. Look for the H bond. That's the hydrogen attached to an NO or F, or FON. People always teach it as phone, which to me was always boring. So I talk about it as NOF. These guys, again, are both nonpolar. And it's what I set up here. When you see only carbons and hydrogens, as soon as you add something like an oxygen or a nitrogen, you have a pool that makes it special. These are nonpolar, so then you look at size. So the C818, because again, it's the larger size, it has 8 carbons versus just 6. What did not show up here, which would win, is ionic. Ionic is going to beat all of these. Ionic is an intermolecular force because it is not, it is just an attraction. So these are forces, attractive forces. That is also another reminder, they may not call it intermolecular forces, they may call it attractive forces. So don't let, that's all that is. All right, question 15 was on a worksheet. It is on there, so let's walk through it. This is where, if it's aqueous, we have to factor in the number of ions. So KBr is 2 ions, so this is going to be 0.4 molal. And the Na2S4 is 3 ions. And that's because it's going to be 2 sodium ions and a sulfate ion. So this is 0.6 or 0.6, 0.4. This is covalent. It is not ionic. So we don't multiply by anything, so it's still 0.35. You recognize it's covalent because we're in this upper corner, the upper right-hand corner of your periodic table. So it actually goes in the order. The highest number is your highest boiling point. It creates an attraction to the solvent, and boiling means the solvent wants to escape. Questions with that page. So again, the study said just takes you through a lot more of these, through all this, and then also through this term. I'm going to move on, unless there's questions. You can always go back. You can always, yeah. All right. So we're going to look at kinetics, and then I'll end with a quick review from this term. But you guys just had a midterm. The study said does bring you back, but I wanted to go through a few things with K. But let's look at kinetics. There are a few questions on kinetics. Do the best you can. Apparently I had a wrong answer on there. See my other sheet, see if I had any other comments. Oh, I do. Actually, I'm going to go back one page. And it was, if you solve something like this, that is only 2 ions. That is a sodium ion, and this whole thing stays together. This has only 2 ions. If it was H2SO4, it would break differently, but that hydrogen stays with the sulfate and the sodium comes off. All right. So these tables. Do you guys want 5 minutes again to play with this page, or you want me to just go for it? Because you're probably tired going, oh, wow, kinetics, don't remember much. With this page, these tables, B doubles, and my rate went up by 4, and A did not change. That tells us it is second order for B. Because 2 to what power would give you 4? So 2 squared gives us a change of 4. When you try to figure out A, you have to do it where the B's don't change. So we have to look at the second and the third equation. So since there's no change in B from the second to the third experiment, I'm looking there. When A doubles, my rate doubles. So it's a direct rate change, 2 to the first power. So our rate law is there's always a rate constant. It's always called K. A is to the first power and B is to the second power. This is called the order. The order for A is just a 1. We don't show the 1, but it could just ask you for a rate law. There'll be, I think there is one of these, and you look at the chart. So like back to the question you'd asked, Aaron, earlier about going back and rewatching videos and redoing a whole bunch of stuff. I would tell you to do that study set 8, and if you get to a question like this and you're like, oh wow, I don't remember this at all, you have one of 2 choices. You can sit there and say it's 1 question, or you can sit there and say, I'm gonna go back and look whoever you had for chemistry 222, you guys would have done these charts and go back. And these were happy places. On my midterm, you all got it right. You all did the charts beautifully. But they're pretty simple and straightforward. You don't have to solve for them with a natural log function or any of that stuff. Question 17 is a half-life question. So natural log of 1/2 equals negative k t 1/2. You can also learn it as negative 0.693, but that's what it is. It comes from the bigger equation, the natural log of, when I was taught this many, many decades ago, I learned them as A's. Some teachers teach them as R's, but it's your final concentration. That T means at some time point because it's never final. It keeps going and going and going. It's still going on. The 0 means A initial, and that would be equal to negative K times some time. So there is a way to do this all as one step, and that's beautiful if you know that. Again, it's one question. Knowing the half-life, that would plug into there. So we'd have natural log of 1/2 divided by our half-life, our 21 years. That's going to give us our K value. That K value we could plug in there, and we would solve for the T now. These are always decay. So the 3.14, which is pi, in case none of you realized, I've been adding another digit to pi every worksheet. And most students have noticed by now, but we're not live, and so we don't have these lively talks. That 3.14159265359 goes in the denominator. The final number goes in the numerator. You'd punch it in. And I have that. I changed my answer over the years. Oh, I have a different answer. Do you guys have this question? Or it has pi in it? I don't know. Great. I have a note to myself about graphs because this question always comes up. Back in 222, there were a bunch of different graphs that showed up at different points. There will probably be one graph. I think there is one graph on there. In all honesty, it's reading a graph. You should have learned that like in 5th grade. See a graph and go, oh, I know how to read graphs. And you read the graph and figure out what it's explaining, and you'll be fine. Right, 18 is those mechanisms. These are actually a big deal in chemistry, and so I'm sure one of these is on there. This is where if you add the steps up, it's kind of like a mini Hess's law, but there's no flipping. That these pieces that we're crossing out, I got two of those. One of these is going to cancel one of those. Those are what are called intermediates, the hubra and the hobra. They never make it to the final, so they're made in one step and then they're used in the next step. So they're an intermediate. That's what people spend their whole career on, is trying to isolate an intermediate to prove their mechanism. So our net equation, we would have all these HBRs. Yeah, and you would pull down what you're left with. The rate law is always based off the slow step. So the rate equals K, and it is the stoichiometry of the slow step. It is your moles in your slow step. So the stoichiometry of the slow step gives you the orders. Since my stoichiometry is just ones, these are both to the one order. Right, energy diagram. I know there's one of these on there. So comment I would make for you is make sure you read the question. Don't feel rushed and assume and like look at it and say, oh, I'm assuming what the question's asking. Like your teacher has done like twice on this handout. So energy diagram, let's do this one. Oh, did I tell you? I said it's endo. Okay, of course. So your teacher, again, has made an assumption. So I was trying to prove a point there. That is exo, what I just drew. So exo means you're starting high and ending low. And I'm here telling you it's endo. So I could joke and say I was doing that on purpose. So this is exo. Let's do both of them for for the heck of it. The activation energy is the energy from your starting point to the top of the hill. The change in heat is from your starting point to your ending point. So exothermic, because we end up lower, so we're losing heat, we get a negative heat. All right, to do endothermic, you're going to end up higher than you started. So from the beginning to the end, that's your positive delta H. The activation energy is all the way to the top of the hill. It is from the bottom of the hill all the way to the top. What a catalyst does is it lowers the hill. Now, I didn't draw my pictures the same size, and I should have. I would have if I had a chalkboard. But this term, we suddenly talked about equilibrium. Probably when you learned these diagrams, your teacher made this comment. This direction is endo. The other direction is exo. So this is my activation energy, is from here to the top for the endo direction. So that's going in my endothermic direction, which I said we were going. If we went in this direction, my activation energy is much smaller. It's only from the starting point to the top of the hill. So like what I drew here, it would just, they're mirroring each other. So reactions are reversible, and kinetics is just always taught right before getting into equilibrium. There is a connection. A catalyst lowers the activation energy. In biochemistry, those would be the enzymes that are used. Yeah. Trying to think if there was something else. So if you made a catalyst over here, it would cut the hill down, and your cat can now walk on your hill. There you go. Make your stick cat again. He's meandering. So you don't have to go over the whole hill to get to the other side. It'd be like the bear that went over the mountain. This sheet only has a little bit of equilibrium because there's something I wanted to mention. The homework set is 8 pages. It has more on equilibrium, on thermodynamics, on redox. Le Chatelier's principle definitely shows up. So yeah, if we add NH3, you guys know this, it's going to shift forward. So if you add something, you need to use it. So the NH3 is going to react and move it forward. If we remove the nitrogen, so there's my equilibrium symbol. If I take away the nitrogen, it's going to also shift forward. Because if you remove something, you have to keep making what you remove. So it can go, can move from either side. All right, volume is definitely related to pressure. So a decrease in volume would mean an increase in pressure. So pressure and volume are always inversely related, whether we're doing gas laws, whether we're doing this. We've seen them many times. It shows up in kinetics even. And so high pressure likes fewer moles. So it is going to shift reverse. So the side with fewer moles. This was a question on the first page of the midterm that you guys did yesterday. It didn't have any effect because the moles were the same on both sides. And so I'm happy you got that. I did grade your test. They're there. Welcome to ask questions. Temperature, we look at the delta H. So I've said it many times, and I'll keep saying it. Temperature, volume, and pressure are not related in equilibrium. That's in gas laws. Here, because we're doing it with a chemical equation, the temperature has an effect. It is endothermic. Since it is endo, high temperature is going to shift it forward. because the heat is on the reactant side. Exo shifts it reverse. Think how far you've come in 4 weeks. So 4 weeks ago, when I was first doing this, you all stared at me like, what is she talking about? And now you're like, endo shifts it forward. Yeah, I got that. And so you've come a long way in 4 weeks. It's, yeah. And it's almost over. All right, you could see it like that. You may also, I want to take 2 deviations on this. It would be a question that would say which of these would shift it reverse? And you would go, okay, that would be C. Could also ask which of these would increase the amount of, or which of these changes would decrease the amount of hydrogen. So hydrogen's here on the product, so C again is the only one shifting it reverse. So reverse is going to decrease the hydrogen. And so it's hard to believe from a month ago or the whole term, but this question is going to be like one of those happy spots where you go, oh my God, Le Chatelier's. It shifts this way or that way. Done with it. Another question you might see is where they just give you an equation. They ask you what kind of pressure and temperature do you want? Well, it's endothermic, so high temperature makes it go forward. And looking at pressure, we want a low pressure to make it go forward. These 2 variables are not related. Could be high, high, low, low, high, low, low, high, whatever you got. All right. The last question is on there. You will also have a question. Like I said, the exam 1 multiple choice should be that you can go through it and see the answers now. And you're welcome to ask me questions. I have this on here because you guys just had on your midterm. Hess's law, I'm pretty sure shows up twice. Once with thermodynamics, like it did on your midterm. In thermodynamics, if you double the equation, you double the delta H, you double the delta G. If you flip the equation, you change the sign. With K's, it's different. So we flip the equation. So we're saying we take K1, and I can see my chlorine and water on the other side. And so what you do, K2 is going to be equal to 1 over K1. So when you flip it with K's, you do an inverse. The other difference is I cut it in half. So with Hess's law that was on your test with thermodynamics, you cut the whole delta H in half or the delta G in half. With this, we would take it to the 1/2 power. So it would probably say K1 to the negative 1/2 power. That's the same thing as this. I wanted to mention that because it will give it to you one way or the other, and I honestly don't know. So 1 over K is the same as K to the negative power. And then the 1/2 power is the same as also saying 1 over the square root of K1. So all of those are what K2 would be equal to. And it might give it to you where it's not numbers, it's just wanting you to rearrange. Those are all saying the same thing here. I also want to remind you, if it was Hess's law and we were adding the equations together, in your exam you just did, if it's delta H's, delta S, delta G, it's all adding. If it's K's, what are you going to do? If we added the equations together,
Multiply.
you are right, Aaron. You would multiply. And for those who like to send me an email and tell me the answer, that would be what you could send. You would have to make it through this whole thing. I don't know if I hit the 119 2-second mark, but we will see. So when you add K's together, you multiply. So I wanted to remind you of that. There's one other thing I wanted to remind you of because it was something a couple people messed up on the exam. So keep in mind when you're doing the test, stay focused, be very calm, be in a quiet place. Make sure you get sleep. So for some of you, that's going to be doing it at night because you're a night owl. Some of you, it's going to be doing it at 5 o'clock in the morning because nobody else is up in the house. And it means you got a good night's sleep. You're going to be fine. There is a curve built into it, so just do it. Do the study set before you do it so you feel fresh. The comment I wanted to make was with ease, because it was a mistake several people made. If you double an equation, you do not double the E. You add e's together, you flip the sign, so when you change the equation, we change the sign, but you never double the E. And you don't square them, you definitely wouldn't do that. Any questions you guys have before I stop? And again, if you have specific questions, you can ask when you do your class presentations during that time. And I will probably have office hour at noon on Thursday and Friday, or somewhere around there. And then at 6 o'clock, I'll check in, or you can send me an email. If you're having questions on the study set, and a couple of people have already asked, you can also choose to just take Thursday off and then study Friday and take it Saturday morning early when it's really quiet on Saturday mornings because everybody sleeps in, right, in your houses. Don't go out and party Friday night. You can do that Saturday. All right. No, I'm going to stop.